In this chapter, we're going to be reviewing and introducing concepts in geometry and transformations. In this lesson, we're going to look at transformations, reflections, and lines of symmetry.
Okay, now in this part of this chapter that we're working through, the material takes a bit of a different twist. Okay, we're kind of going off in a different direction. We're going to take a look at transformations, and then we're going to look specifically at reflections and lines of symmetry and whatnot as well. But specifically transformations, and in this particular lesson, translations. Now, a transformation is when you take an object and you change its position, and we've got these highlighted here. Okay, it's the position, the orientation, and then the size or shape of the object, which could mean a stretch here, okay? So by position, we typically refer to this as a translation, okay? When you're moving it left and right or up and down. Orientation, maybe we're talking about a reflection here. So that all of a sudden the object, maybe it was pointing one way, well now it's pointing another way, so it's orientation, or we rotate it, okay? Reflection, it could be a rotation. We could change the size and or shape of an object, and we usually think of this as a dilation, okay, where it's getting bigger or smaller, but maybe we're only stretching it in one direction, which is why we say we change the shape of an object. It's not like we're taking a square and turning it into like a circle or something like that when we say we change the shape. Mostly like you think about like a square, then you stretch it in one direction so it becomes a rectangle. Something more like that. Anyway, let's take a quick look at what we mean by these. So a translation is what happens when you change the position of an object by moving it horizontally or vertically. Okay, and it does not alter the size or shape of that object. It's just the position. Now, normally what that means is we're going to take the points of an object here. We're going to take some point x comma y on the object. So let's say we take this one right here. And what happens is we're going to take that and move that object to this point right here. So what we end up doing is we end up, for example, I'm going to add some sort of a number to x, and then I'm going to add some sort of a number to y. And it's the a and the b that become the translation. Now, bear in mind here, a could be negative. So for example, in this situation right here, I want to move this piece to here. Now notice, if you count out the bricks here, the blocks here, it's not 1, 2, 3, 4, 5, 6. This block didn't move 6 to get here. There's a 6-block gap in between them, but I need this piece to move to here, which means it moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It moved 10. So the way that I might translate it, the way I might talk about it, is I'm taking every x coordinate here and I'm going to subtract 10 from it. Now, the y coordinates didn't move. It didn't move vertically. So I might say y plus 0, or I might just leave it all by itself. But then I could use this. Once I've identified that this is how things are moving, I can get kind of lazy. Once I know all the coordinates of this point, of this box right here, I can just use this little formula to get all the rest of them. Okay, so this is just a nice convenient way of talking about a translation here. Now, we might talk about a reflection where we're going to flip things over here. Now, for what we're going to do here, we're not going to overly complicate this. We just want to get this idea here. So the reflection is the mirror image of the object created over the reflection line. So we've got this object here, and then we've got this mirror line, this reflection line. Really what we want you to get out of this is, see this point right here? It's 1, 2, 3 units away from the line, which means its reflection is going to be 1, 2, 3 units on the other side of the line. Because this point right here is 1 unit away from the line, its reflection is 1 unit away on the other side of the line. That's all we're going to do here. I'm not going to worry about creating little coordinates here and giving you rules for the coordinates, mostly because that's going to depend heavily on where that line is. And we're going to be a little bit free with the line. We're going to kind of put the line wherever we want it. And so all I really want you to catch out of this is that this jump is the same as this jump. Okay? This jump right here is going to be the same as this jump right here. And just as long as you're consistent with that, you'll be fine. The last thing that we want to talk about in this particular lesson here are just lines of symmetry. Okay, we want you to recognize symmetry. Symmetry is so important in not just mathematics, but in art, in culture. We love symmetry. We like things to be symmetric. There's some interesting arguments made that as people here, we find symmetry in other people to be beautiful. The more symmetric a person is, the more beautiful we find them. So this is why you don't see pictures of me or my face when I'm doing this, because I'm not terribly symmetric. So that's okay though. So we like symmetry here. So people, humans here, have what we call this vertical line of symmetry. They got one line that cuts through them, and we are basically the same on the left hand and the right hand side of that line. Other objects have other lines of symmetry that we're going to explore here and take a quick look at. Anyway, so these are the ideas that we want to explore. Now let's take a look at some questions. Okay, so our first question here that we want to work through here says, translate the following image 6 units down and 4 units to the left. Okay, 6 units down and 4 units to the left. So, okay, before I look at this here, what I'm going to do is I'm going to take a look at our points here. So we're going to have our points x comma, whoops, you can't see that, x comma y. And then to translate that, we're going to go 6 units down and 4 units to the left. Now remember, up and down, that's a y-coordinate thing, okay? It's the vertical axis is the y-axis. So 6 units down means I'm going to take the y-coordinate and I'm going to subtract 6 from it. 4 units to the left, now 4 units to the left is this way, okay? And so the numbers, the x numbers get smaller when I go that way. So that's basically meaning I'm going to take my x-coordinates and I'm going to subtract 4 from them. Okay. So now what I need to do is I need to get a list of points here. I need to get my A, B, C, D, and E points from this graph here. And actually, this is what I find to be, for some people, this is a difficult thing to do. I've noticed this with a lot of people, that they flip the points. Okay, every point should be x comma y. But a lot of people, when they go to find point A, they go up first and then over. You're supposed to be going horizontally first and then over up to A here. So to get to A should be starting from the origin 1, 2, 3, 4. So 4 comma, and then from the x-axis I'm going to go up here 1, 2, 3, 4, 5. So A is the point 4 comma 5. B. To get to B, I got to go 1 horizontally, 1 to the right, and then up 1, 2, 3 to get to B. For C, I go from the origin 1, 2, 3, 4, 4 to the right, so positive 4, and then I have to only go up 1 to get to C. Now to get to D, I got to do a little bit more here. So starting at the origin, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So that'll be 8 to the right, and then 1, 2, 3, 4, 5 up. And then to get to E is going to be, I got to make sure I line that up there, 1, 2, 3, 4, 5. And then 1, 2, 3, 4. Okay, so those are our points. Now what we're going to do is we're going to translate that over. Now the easiest way to do that though is going to be to find the coordinates first and then plot them. Now for some of you you're going to find this bit of math that we're doing here to be really trivial, because you're going to have your brains are going to be kind of hardwired where that sort of spatial reasoning is really easy to you, which is awesome. That's fantastic. Not everybody is in that same position, okay? So just be aware of that. Not everybody finds that super easy to do. So this is why I focus on this particular tool right here. So what I want to do is I'm going to come up with a brand new A value, and I'm going to subtract 4 from that. So 4 minus 4 is 0, and then I'm going to subtract 6 from 5 to get negative 1. So maybe I'll do this as we go here. So the point A goes to the point 0, negative 1. So here's my new A coordinate. B, and I'm going to use little a primed to show me what I'm doing here. B, I'm going to subtract 4 from 1, so that'll be negative 3, and then I'm going to subtract 6 from 3 to get negative 3. So B is going to be 1, 2, 3, 1, 2, 3. So here's B. B primed. C, well, I'm going to subtract 4 from the x value. So 4 minus 4 is going to be 0. And then 1 minus 6 is going to be negative 5. So from C, I'm going to start here and go 0. So I'm not going to move anywhere. Then 1, 2, 3, 4, 5. So here's C. D, to get my new D value, it'll be 8 minus 4, which is just going to be positive 4. But then 5 minus 6, so again, the negative 1. So 1, 2, 3, 4. And then this is going to go down 1. So D is going to be right here. Whoops, D. And then finally E. 5 minus 4 is going to be 1. And then 4 minus 6 will be negative 2. So that's going to be 1, and then 1, 2. So our new E value is going to be right there. And so then we connect the dots. And so the final result is a motion 4 to the left and then 6 down to get to our new graph. Okay, now this question's a little bit easier than what we were just doing. It says, which shape, 1, 2, or 3, is a translation of the shape ABCD? So we're looking at this one right here. Which of the following shapes is just a translation? And then once you've identified it, how far did it move horizontally? How far did it move vertically here? Okay, well, to be a translation, okay, it cannot affect the size, okay, or the orientation of the shape here. So, and when I say orientation, immediately I can see that 3 doesn't work, because this little point down here is on the left-hand side of the shape, and over here it's on the right-hand side of the shape. So that doesn't work. A translation won't flip the graph like that. So it's either 1 or 2. Now, let's take a look at the size here, because there is a size difference between 1 and 2 here. My shape right here from top to bottom is 1, 2, 3, 4, 5 units tall. 1 here is 1, 2, 3, 4, 5 units tall. Okay, that's good. This one here is 1, 2, 3, 4, 5 units tall. Okay, so something is, okay, so the size here isn't the issue. They're both 5 here. So what is it going on here? Well, it's not the width, because I can see that in every case here it's the width. So maybe it is something about the shape. Maybe the shape has changed. And actually that is the case here, because take a look at the bottom part right here. Notice that to go from A to E, it is 3 units over, but it's 2 units up. From here to here on the corresponding part, that's only 1 unit up. Whereas over here for 2, it is 3 units over and 2 units up. So actually this moved to here. It's not 1, it's got to be 2. So 2 is the shape. Now, how did it move? Well, let's pick a point here, and let's pick A, because A is really easy to identify. A moved to there. So from here, let's just count it out. Now, when you start counting out the move, don't start counting at A. Put your pencil on A, and then count every little step that you take from that point on. So starting here, then it's 1, 2, 3, 4, 5, 6, 7, 8 units. So it's 8 to the right. And then from there, it was just 1 down. And those are the translations that we're applying to this shape to get it to there. Okay, well, for this question right here, it says that the shape below is translated so that the point A primed, so that's the A, okay, has been moved to -1, -6. So that means -1, then 1, 2, 3, 4, 5, 6. That means it's right down here. There's my new A value. Okay, we want to draw the rest of the transformed image, which actually is quite easy from this point on, and then state the coordinates of the new points and identify how the shape was transformed. Well, first of all, let's identify how the shape was transformed. For A to go from here to here, and if I put my pencil here on A, or my marker here on A, and count it out, it's going to be 1, 2, 3, 4, 5, 6. So this has been moved 6 to the right. And that put me here, and then to get back down to this, it's going to be 1, 2, 3, 4, 5 down. Okay, 6 to the right and then 5 down. Now let's take the rest of our find the rest of our points here. So notice that B, okay, is 1 unit over, 2 units up from A. So it's going to be 1 unit over, 2 units up. So B is going to be right there. B primed is the point, well, it's 0. It's right on the y-axis, and then 1, 2, 3, 4, negative 4. So 0, negative 4. Okay, and I'm just going to double check that I did that right. So that should be 6 right and 5 down. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, and so that's good. That works. Now from B, C is 1 unit back and 3 units up. So C primed is going to be 1 unit back, and then 1, 2, 3, and there's my C primed. Now let's just take a look. What coordinates? Well, that's easy to figure out. That's 1 to the left, 1 down. So negative 1, negative 1. Does that still work? So starting at C, is that 1, 2, 3, 4, 5, 6? Yeah. 1, 2, 3, 4, 5. Yep, it's still 6 over to the right and 5 down. Good. Now D, well, D was 1, 2, 3, 4, 5 units just straight over from A. So let's just do that. From A prime, it's going to be 1, 2, 3, 4, 5 units straight over. Wait a minute. 2, 3, 4, 5. For a second there, I thought I miscounted that. So D prime is going to be over here. Now let's count out D. That's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So it's going to be 4 comma negative 6. Now we just want to connect the dots and make sure that we've drawn in our shape. Okay, and there you go. That's what we're asking you to do here. Once you've got one point, if you can read off how all the other points relate back to that one point, you can draw that new shape in whatever position it needs to be in. Okay, this question says reflect the following image about the y-axis and then reflect the original again, but this time about the x-axis. So here's our original. All we really want to do right now is, and it's because we're going to change where those reflection lines are frequently here, is you just want to make sure we count this out here. So this point right here is 1 unit to the right, so its reflection is going to be 1 unit to the left of the y-axis. This point right here is 2 units to the right, so that's going to be 2 units to the left of the y-axis. Okay, and notice that we're keeping it on the same kind of horizontal level here. This point right here is 1, 2, 3 units to the right, so we're going to go 1, 2, 3 units to the left. And then this point here along this line is 1, 2, 3, 4, 5, 6, 7 to the right. So 1, 2, 3, 4, 5, 6, 7 to the left. So now we're just going to connect the dots. Okay, and there we go. Now let's use another color here. This time we're going to reflect it over. Oh, well, that's not the shape at all. That's not the shape at all, how that's supposed to work here. Shoot, I did that wrong. Oh boy. Okay, I'm so sorry, everybody. As soon as I looked at it, I was going to make a comment about what the shape looks like, and I realized that's not it. Okay, let's try that again. This point here was 1, 2, 3. It's going to go right there. This point was 1, 2. Well, it was out here. I know that. This one was right there. Okay, the way that shape should have worked is it's going to go down to there, out. That's what that reflection looks like. Wow! My head was in a different place altogether for that quick moment right there. Yeah, so these should be kind of appearing to open up here, okay, right? As this one moves away from the y-axis, so does this one. Okay, that's what that should look like. Now, let's do the same thing to this one, but over the x-axis. So this time things that are going to be on the same vertical, this point on this vertical line is going to stay on that vertical line, but it's 1 unit above, so now it's going to be 1 unit below. This point here is on this second vertical line, but it's going to be 1, 2, 3, 4, 5, 6, 7 above. So 1, 2, 3, 4, 5, 6, 7 below. This key point is 1, 2, 3, 4 above, so 1, 2, 3, 4 below. This one way over here is 1, 2, 3 up, so 1, 2, 3 below. Now I just got to make sure that I connect this correctly. So it's going to go up to there, like that. Yeah, that looks way better. Way better. Okay, and so when you see these reflections here, you start to get kind of basically like a flower shape, okay, where you got the center here, and these are like your little petals here when we start to reflect them around the axes like that. Okay, now for this one right here, we're being asked to draw the lines of symmetries in the following masks. Now, we're not supposed to worry about the color. Don't worry about what you're seeing here in terms of color. We just want to worry about the shape here. So look at the Canadian flag here. There really is only one line of symmetry, and that is right down the center. Okay, this could be folded over and they would match up perfectly right there. Let's take a look at the Austria flag. Now again, ignoring the colors here. Now Austria's got a couple of lines of symmetry. I could fold this right along that center line, and these rectangles would perfectly overlap. But I could also fold it this way. Okay? And when I fold that over, again, those pieces would completely overlap. Now, let's take a look at the United Kingdom. And at first it looks like you might think, well, there's two lines of symmetry. Oh, but look at the shape again. These bars here kind of stop it from being symmetric like that. There is actually no line of symmetry there. It doesn't work. Now, the Indian flag right here, this is an interesting one. Now, technically, if we're going to consider the rectangular shape, then we've got a line of symmetry through there, and then we've got a line of symmetry through there. Don't worry about, okay, don't worry about the colors, but I can fold this over completely. I can fold it over completely this way. Now, if you just look at the middle portion here, though, if we just look at this middle bit right here, actually there are more lines of symmetry here. I could cut it this way. I could cut it this way. 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12 before I bump into myself to my other line here. There are actually, for this central portion here, there are 12 lines of symmetry. But if I zoom back out, whoops, the wrong way. If I zoom back out, because of the overall rectangular shape, there really are only the 2 lines of symmetry. So I like this one. Like that. That's an interesting flag to look at here. Now, let's take a look at the Brazilian flag. And yeah, there's no line of symmetry here, right? Because of the distribution of the stars here and the banner across here, there's no line of symmetry there that we can draw through. And actually the same thing happens here for the South Korean flag. Because of the differences in the glyphs here on around that central shape here, can't do that. Now, if you ignore that though, then there is some symmetry here, okay, but it's more like a rotation symmetry than anything, okay. Although you could cut it kind of along the middle there and flip it kind of along there and flip it as well. There really are no overall lines of symmetry for that flag.